Okay, so let's unpack this. Today we're doing a deep dive into a very specific piece of technology.
A really interesting one.
Yeah, one that quietly solves this huge infrastructure headache for places like, hospitals, universities, big hotels. We're looking at the Thor Broadcast H-THUNDER-4.
The 4 HDMI digital RF encoder modulator.
So the mission here, really, is to figure out why this one box is so critical. I mean, the problem it's trying to solve seems simple on the surface, right?
It does.
How do you take a high-definition digital video signal?
Like from a security camera feed or something.
Exactly, and then broadcast it across, the existing, sometimes ancient cable TV wiring in a massive building?
You need a translator.
A translator, that's a perfect word for it.
It is. It is the translator. It basically does two really crucial jobs for these legacy systems.
Okay, what are they?
So first, it encodes,
Right.
which just means it's converting your clean digital video, your HDMI signal, into a broadcast standard.
MPEG-2 in this case.
Right, MPEG-2. Then it modulates. It takes that digital stream and turns it into a traditional radio frequency signal.
An RF signal, so the kind of signal that literally any old TV can just pick up.
Any TV, any set-top box.
Yeah.
Exactly.
And the initial sort of wow factor here is the quality it maintains. We're talking full HD, 1080p 60.
Across 4 separate inputs, yeah.
But I saw it's also HDCP compliant. Why would, say, a hospital care about that? What does that actually mean for them?
Oh, it's absolutely vital. It's HDCP is high bandwidth digital content protection.
The copy protection.
The copy protection, exactly.
Yeah.
So if your source is a Blu-ray player or a satellite receiver, something that's usually protected,
Right.
you need that compliance. Without it, the signal just won't pass through. It blacks out.
So it turns it from a neat little workaround into a proper enterprise solution.
That's the key. Yes.
So let's get a bit more into the technical side of this. You mentioned MPEG-2 encoding. What really jumped out at me was the low latency. They're specifying 50 to 100 milliseconds. Why does that speed matter so much in the real world?
Well, think about a live feed. If you're watching, say, a camera from a surgery
Okay.
or a security camera in a casino.
Right, a real-time situation.
Exactly. Low latency means there's practically no delay between the action happening and you seeing it on the screen. It keeps it almost instantaneous. And the audio is solid, too. It handles everything from AAC to DD-AC3, so the sound quality stays high.
Okay, now here's where it got really interesting for me, especially for like a global deployment. Let's say a big hotel chain installs one of these in the US where we use the ATSC standard.
Right.
Can they just take that exact same box and ship it to their hotel in Germany, which uses, what, DVB-T?
They can, absolutely. And that's the strategic brilliance of this device.
So it speaks all the languages.
It speaks all the television dialects, as you could call them, ATSC, DVB-C, GVBT, ISDBT.
Wow.
It has dynamic switching built right in. So it just becomes this universal plug-and-play solution. It completely removes that huge cost of needing different hardware for different regions.
So if we connect that to the bigger picture, it feels like this is just massive component consolidation in one box.
It is.
But you mentioned it's a less expensive model because it only does CATV RF output. It doesn't do IPTV.
That's right.
So what's the implication there? What are you giving up?
You're giving up the ability to stream over a modern Ethernet network, which is what IPTV is.
Okay.
But in doing so, they made a trade. They focused the device entirely on the existing coaxial wiring. It lowers the price, and it makes it absolutely rock-solid stable on those legacy cable systems.
So it's perfect if you want to avoid a massive, costly rewiring job.
Exactly, or setting up a whole new network infrastructure.
And what about managing it? I see it uses a web-based NMS, which is pretty standard.
Yep, network management software through a browser.
But it's also TAA compliant. What does TAA mean for the person buying this?
TAA is the Trade Agreements Act. For a customer, it means the hardware is made either in the U.S. or in an approved country. And that's often a mandatory requirement for, say, government contracts, defense, federal healthcare systems.
So it's a huge logistical checkmark for any big institutional buyer.
A critical one.
Yeah.
Yes. And just to round out the specs, it operates on a huge RF frequency range from 100 to 1,000 megahertz.
So it can slot in anywhere on an existing cable plan.
Anywhere. That universal flexibility is really why it sits at its current price point, which is around $1,985.
So when you boil it all down, what does this all mean for you, the person who might actually need to deploy this kind of tech?
Well, we've basically seen how a single box can act as this universal high-def translator.
Mm.
It lets you bypass all those complex, really expensive infrastructure upgrades in pretty much any legacy building anywhere in the world.
Which I think leaves us with a really important question for you to think about.
If a single piece of standard, off-the-shelf commercial hardware can dynamically switch and broadcast across, well, virtually every global television modulation standard, does that suggest that the underlying foundations of global TE broadcast are actually far more interoperable and easier to manipulate than most of us outside the industry even realize?